Okay, this is the second vodcast for Unit 7. It's on balancing chemical equations. This is the last vodcast for the C work. So, what a balanced equation is what it means is it has each side of the equation has the same number of atoms of each element on the left side of the arrow and the right side of the arrow. So what I'm saying here is if I've got 2 carbons on the left side of the arrow, on the right side of the arrow, I need to ultimately have 2 carbons. And when that's the case, we say it's balanced. When that's not the case, we say it's unbalanced if you have an uneven number on opposite sides of the arrow. Well, one of the reasons why we do this is the law of conservation of mass. And I want you to check your notes here. They might say matter. It should really say mass there. So check for that typo. The law of conservation of mass says mass cannot be created or destroyed. It's always conserved. Cannot be created or destroyed. It's always conserved, which means you keep it. Okay, in plain and simple terms, what you start with is what you have to end with. So whatever you start with in your reactants in terms of elements and how many there are is what you need to end up with in your products. Now you've got a couple of rules for balancing equations. Ultimately you'll be able to do these without the rules, but you want to follow along and learn the process. The first thing you want to do is make sure you have the correct formulas and physical states. Okay, physical states are the ones I taught you in the last section: solid, liquid, gas, and aqueous. Okay, typically that's provided for you unless you're doing the advanced A and B work. You might have to figure some of that out on your own. You want to make sure you have the reactants on the left and the products on the right. Again, with the C work, this will already be done for you. Some of you will be learning how to write chemical equations from words, and so this is what you would be doing for those first steps. Now here, this is where most of you will be starting for the C work. You want to count the number of atoms of each element in the reactants and the products. So you want to take inventory. So sometimes this is called the inventory step, where you count up and you see what you have. And then you want to balance the equation using coefficients. And you don't ever want to change the subscripts. So balancing equation using coefficients. Coefficients are the big numbers in front, like I was showing you in the last vodcast. So big numbers in front. You never want to change the little numbers at the bottom. Okay, so don't change subscripts. Those are the little numbers at the bottom. You're only going to do the big numbers in the front. And then when you're done, you want to make sure each atom or polyatomic ion, you want to check them all to make sure you've got the same on the left and on the right. And then you want to make sure the coefficients are in the lowest possible ratio. You might end up with something like 2Ag plus, let's say 2NO3 makes 2AgNO3. You see how I've got the 2, 2, and the 2? Well, I could reduce those to 1, 1, and 1. So I want the lowest possible coefficients. Okay, so I'm going to run through a bunch of examples with you guys and follow along and try these out on your own. You know, I've already got the reactants and the products written and the chemical state. So really I'm coming in at step 3, which is taking inventory and seeing what I have. Here I've got 2 hydrogens on the left and 2 hydrogens on the right, and 2 oxygens on the left and only 1 oxygen on the right hand side of the arrow. So 2 oxygens, and then here I only have 1 oxygen, like that. Well, I can't change the little numbers down at the bottom. I can't put a little 2 down here because that changes what the chemical is. Okay? The only thing I can do is add big numbers in front. Well, the hydrogen's okay. I've got 2 and 2. That's even for right now. But the oxygen, 2 and 1. So what I want to do is, the only thing I can do is put a big number in front, like that. Now, that changes my number. That big 2 in front goes on everything in there. It multiplies on everything in there. So now, instead of having 2 hydrogens, I now have 2 times 2. I have 4 hydrogens. And now I have 2 times the invisible 1. I've got 2 oxygens on the right-hand side of the equation. So now the oxygens are good, but the hydrogens are messed up. I've got 4 on the right and 2 on the left. So I need to fix that. And the way I can do that is by putting a coefficient in front. So there's a big 2 in front. Now I have 2 times 2. I've got 4 hydrogens. So I have the same number of hydrogens on the left as I do on the right. One thing you want to do is you want to go back through and check one last time. 2 times 2 is 4 hydrogens, and I have 2 times 2, 4 hydrogens on the right. On the left, 2 oxygens, and on the right, 2 times my invisible 1, 2 oxygens. They match up, and now I can say this equation is balanced. This right here, I can leave blank. It's an invisible 1. Okay? Typically, they are not filled in. Let's look at this one here. CS plus O2 makes CO2. Take inventory. See what you've got. On the left, I have 1 carbon and 2 oxygens. On the right-hand side of the arrow, I've got 1 carbon and 2 oxygens. So in this case, this one is automatically balanced. Sometimes you have that situation where they're the same on the left and they are on the right, and you don't need to do anything to them. Okay, let's try another one here. Mg plus N2 makes magnesium nitride, Mg3, N2. So on the left, 1 Mg, and then 2 nitrogens. And on the right, I've got 3 Mgs and 2 nitrogens. Well, for the moment, the nitrogen looks good, so I want to deal with the magnesium. On the right-hand side, I've got 3. On the left-hand side, I only have 1. So the only thing I can do is put a big number in front, which would be a 3. So that would give me 3 magnesiums. And so 3 magnesiums, 2 nitrogens, 2 nitrogens. This one is now balanced. Let's do another one. Okay, notice these are also all, these here on this slide are all combination reactions, because on your assignment you're also going to be naming the reaction types. RXN right here, that's the abbreviation for reaction. So looking at the bottom, you should be able to do this one on your own. I've got 1 phosphorus, and over here I have 4 phosphorus. And on the left-hand side of the arrow, I have 2 oxygens, and on the right-hand side of the arrow, I have 10 oxygens. It generally does not matter where you start, okay? You're going to want to do these in pencil because you're going to be changing numbers on some of them, okay? So I'm just going to start with phosphorus because it's the first one there. On the left, I've got 1. On the right, I have 4. So I need to make this 4. This now gives me 4 phosphorus on the left, 4 phosphorus on the right. On the oxygen, I've got 2 on the left and 10 on the right. Well, I'm looking for some number that multiplies by 2 to give me 10. So 10 divided by 2 gives me 5. And so now I have 10 oxygens on the left and 10 oxygens on the right. You always want to go back and look, make sure you've got it. 4 phosphorus, 10 oxygens, 10 oxygens, and I'm good. And again, this is an invisible one right here. Just leave it blank. You can put in the ones on your worksheet if you want to, but it's not necessary. Some students like to have all the blanks filled because it looks more complete to them. But if you leave them blank, that's fine. Now, this method that I've been doing is the inventory method, where I count them on the left and I count them on the right. Some of you soon will be able to do what's called balancing by inspection. And, you know, to inspect something is to look at it. And so some of you will probably just be able to look at them and balance equations. And you may be there already, or you will be in a few days. But that's easier than writing all the stuff at the bottom. But at the beginning, you might want to do that actual inventory where you write it down. So let's take a look at the first one here. This first one, if I look at what's happening, I've got parentheses on the NO3. These parentheses here. Those parentheses mean I have a polyatomic ion. When you have a polyatomic ion, the easiest thing to do is to look for it on the other side of the equation. And over here, I find it next to the Ag. Now, sometimes I find that it helps that you draw parentheses around the polyatomic ion if they're not there already. That way you think of it as a group. Okay? This is a single replacement reaction. I know because I have a single copper on the left hand side and a single element silver on the right hand side. And the silver and copper are trading places. So if I look at the equation again, I've got 1 silver and 1 silver, 1 copper and 1 copper, but then on the right hand side I have this little 2, and that means I have 2 of the nitrate groups. And on the left hand side there's no number on the nitrate. In fact, I had to draw in the parentheses, which means I only have 1. So in this particular situation, it's my nitrate groups that are out of balance. 2 nitrates, and over here I only have 1 of that NO3 group. So the way to make it even, I can only put big numbers in front. I draw the 2 in front. Now that changes my Ag. Now this is saying on the left hand side that I have 2 silvers. So on the right hand side I need to make 2 silvers. And this is more what's called balancing by inspection, where you just kind of look at it and tweak the equation. Okay? When you balance by inspection, it's important to check everything one last time. Okay, so I'm just going to clean this up so we can see it a little neater here. Your final answer. I've got 2 Ags on the left. I now have 2 Ags on the right. I have 2 of the NO3 groups on the left. I've got 2 of the NO3 groups on the right. And then I've got 1 copper on the left, 1 copper on the right, and I'm good. Okay, so always check one last time, especially when you're balancing by inspection. Let's look at this next one here. MgSO4, that's magnesium sulfate plus potassium hydroxide, the KOH. It makes magnesium hydroxide and then the potassium sulfate. This one's a double replacement reaction. I have the magnesium and the potassium hydroxide, or the potassium trading places. I also see parentheses, which tips me off that I have a polyatomic ion. Okay, so I've got the parentheses on the right around the OH. Again, it helps to draw in the parentheses so you can see them. And then I also have sulfate. Sulfate's also a polyatomic ion. SO4, SO4, like that. And I want to look for things that are different. Okay, I've got one magnesium on the left, one on the right, one sulfate group on the left, one sulfate group on the right. I've got one K on the left and two Ks on the right. So that's what I need to fix. So I need to put a 2 in front of the KOH so that I have two potassiums. Well, that's going to mean I have two of the OH groups. And I look on the right and I've got two of the OH groups. And so you always just want to go through and check one last time to make sure you've got everything. You always want to go back through and check one last time to make sure you've got everything. One magnesium, that's good. One of the sulfate group, there's one of the sulfate group. Here's two of the Ks, two of the Ks, two of the OH groups, two of the OH groups. It's all balanced in this case. Now, you could do it atom by atom. On the left, I've got one Mg, I have one sulfur, and I've got 4 oxygens there. Here now I've got 2 Ks, 2 oxygens, and 2 hydrogens. So that means I have a total of 6 oxygens on the left hand, 6 oxygens on the left hand side of the arrow, and I still should have 6 on the right hand side of the arrow. But when you're doing polyatomic ions, it's a lot easier to leave them complete and whole as much as possible. Okay, so let's look at the next one. I've got Na plus water makes NaOH, sodium hydroxide, and H2O. Okay, nothing's jumping out at me as a polyatomic ion when I first look at it because I don't see any parentheses. I notice I've got 2 hydrogens here on the left. On the right, I've got 2 plus 1. I've got 3 hydrogens on the right. And so that's what's uneven at this point. Well, what's really helpful is remembering that water can be written as HOH. I was hinting at that in an earlier vodcast. When I rewrite water as HOH, it becomes obvious I have this hydroxide group, the OH there. And so that makes my balancing a little bit easier. Because now I have one sodium, I have one of the OH groups, there's one of the OH groups, and now I have one lone hydrogen on the left and 2 on the right. So I know right there that's what's out of whack, is the hydrogen. Okay? So since I have only one hydrogen on the left, I need to put a big 2 in front so it matches the 2 hydrogens on the right. Well, when I put that big 2 in the front, that also gives me 2 of the OH group. So I need to put a 2 in the front. So now I have 2 of the OH groups. Well, that's going to give me 2 of the NAs of the sodium. So I need to put in a 2 for the sodium there. Okay, so this is balancing by inspection. When I don't take inventory and I just look at it and fix it as needed. And again, you always want to double check on balancing by inspection. 2 NAs, there's 2 NAs. I can look here, 2 times 2 is 4 hydrogens. And on the right hand side of the arrow, I've got this big 2 in front. That gives me 2 hydrogens plus 2 more hydrogens from the H2. Okay, I can add them together like that. So I've got 4 hydrogens on both sides. And then the oxygen, 2 times 1, I've got 2 oxygens. And on the right hand side, I also have a 2 times 1, 2 oxygens. So this one is now considered balanced. Okay, your last type of reaction to balance is combustion reactions, and these will probably be the ones that are most challenging for you. In all the other reaction types, it really didn't matter where you started. You just picked out something that was uneven. But with combustion reactions, if you'll notice, you've got oxygen in two places on the right hand side of the arrow, and so that can make it a little challenging to balance. So with combustion reactions, I tell people to remember chocolate. Okay, most everybody loves chocolate. And so you've got chocolate starts with CHO. So that's the order you're going to balance in. First you're going to do carbon. And then after you're done with your carbon, you're going to do hydrogen. And then after hydrogen, balance your oxygen. There's your chocolate. Carbon, hydrogen, oxygen. So let's do that here. I've got one carbon on the left, one carbon on the right. So far, so good. I've got 4 hydrogens on the left, and over here I've got 2 hydrogens, so I need to put a 2 in front to give me 4 hydrogens on the right. Now I can do oxygen. I've got 2 on the left, but then on the right hand side of the arrow, remember we have to add up all the oxygens. I've got 2 oxygens plus 2 more oxygens for a total of 4 oxygens on the right. So I need to make 4 on the left, which means I put a 2 there. And that gives me 2 times 2, 4 oxygens. Always check one last time. 1 carbon, 4 hydrogens, 2 times 2, 4 hydrogens, 2 times 2, 4 oxygens, which is 2 plus a 2 times 1. 4 oxygens, and so this one's now balanced. Okay, let's try the next one. CH2 plus O2 makes CO2 and H2O. Again, it's a combustion reaction. I know this because carbon dioxide and water are my products. Start with the carbon. I've got 1 carbon on the left, 1 carbon on the right, 2 hydrogens on the left, 2 hydrogens on the right, 2 oxygens on the left, and I've got 2 plus 1, that's 3 oxygens on the right. So that doesn't work. And there's no way you're going to get 3 oxygens on the left because you have an even number. So in this case, when you have something like that, an odd number of oxygens on the right, and an impossible number to get, what you need to do is multiply everything by 2 to make your even numbers odd. So when you hit that point, what you got to do is you got to put a 2 in front of your hydrocarbon. So then let's start there. Now I have 2 carbons on the left, so I need to make 2 carbons on the right. This gives me 2 times 2, gives me 4 hydrogens. So I need to make 4 hydrogens on the right. Now let's count up my oxygens again. 2 times 2, that's 4 oxygens, plus 2 times my invisible 1, that's 2 oxygens. That gives me a total of 6 oxygens. Now I can make the right number of oxygens on the left-hand side. 2 goes into 6 3 times. So now I have 3 times 2. I have my 6 oxygens. So I have 2 carbons, 2 carbons, 2 times 2, 4 hydrogens, 2 times 2, 4 hydrogens, and then I just balance my oxygen. 4 plus 2 more for 6 oxygens, and 3 times 2 is 6 oxygens, and this one's balanced. Okay, so the combustion reactions are the most challenging. On all the other ones, you kind of saw small numbers. Here on the combustion reactions, you can have large coefficients. Sometimes there's one I give you guys where you end up with something like 25 oxygens. It's not impossible, okay? You just got to go carbon first, hydrogen, and then oxygen.